Hello guys, my name is Desmond and I welcome you to my lesson for today where we will be looking at your mathematics. Obviously, as you can see over there, analytical geometry is what we will be looking at in today's lesson. So ladies and gentlemen, please do allow me to say it is very much important that I say it is very, very much important because Rhea, what I'm about to say, it's massively, massive. Oisa, massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. By so saying, Buddha, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very, very much important, ladies and gentlemen, over there. So, as I've indicated, mathematics is what we'll be looking at in today's lesson, specifically analytical geometry. In today's lesson, I'm going to prove it to you guys that it is possible that in one day, within an hour, you can start a chapter from the start until the end and fully understand everything and be in a position where you can be able to answer any question. King Mulauzi, honorable member, remember to mute your mic. So on your screen, there should be a button which says mute. So click on that button so that we do not get disturbed by the background noise. So to all the new learners, a very warm welcome and make sure that your mics remain muted. So I'll just quickly explain to you what's going to happen in today's lesson. This is what we're going to do, a very quick revision on those 3 points, distance, gradient, and midpoint. From there, we are going to look at an inclination of a line, equation of a straight line. Most importantly, this is where you might need to determine an equation of a straight line. And lastly, we will look at the application involving quadrilateral. So that's where I'm going to quickly take you guys through that question paper which was sent in the group. So for the first part of this lesson, I'm just going to do more like a presentation. So all of you guys will be listening. I will from time to time give you guys an opportunity to ask any questions. And then from there, as soon as we are done with the introduction, we will then start to engage some more. Very quickly, the reason why I might not need your engagement on this part is because distance formula, gradient formula, and midpoint is what you learned in grade 10. So I'm just going to quickly take you guys through a revision. Remember, guys, this same lesson that I'm doing today, it's exactly the same lesson that I did yesterday for grade 12s. Meaning, when it comes to analytical geometry, the content is the same. What differs is the complexity of questions asked in exam. Meaning, in this same lesson, you might be having some grade 12s attending. Reason to that is because maths, especially this part of analytical geometry, what you need to know is the same. The only difference, level of complexity. But I'm going to simplify it to an extent where you even ask yourself, what exactly is difficult about this chapter? Okay, very quickly, I want to talk about the distance. Remember, guys, mathematically, when we talk about the distance, it refers to one and the same thing as the length, meaning examiner can use the word distance or the length. They use these words in order to confuse you in a question, but just always remember that length, distance refers to one and the same thing. And we do have a formula for calculating either the distance or the length. And the formula is, let's see, it's x2 minus x1 squared plus y2 minus y1 squared. Remember, guys, there are some instances where I might make some mistakes. In case if you notice a particular mistake, make sure to immediately make me aware of that so that I can quickly correct it, because some of these things, they are coming from my head. So the distance or the length, let's do an example. Remember, we plot functions or lines on a Cartesian plane. What is a Cartesian plane? A Cartesian plane has got the x-axis and also the y-axis, and this point is called the origin. This is what we call a Cartesian plane. On a Cartesian plane, you can draw a straight line, something similar to that. You can also draw a straight line, something similar to that. Let's say from this point up to that point. That's why they might use letter A and then letter B to say from point A to point B. What could be the distance or the length from point A to point B? If we need to label that other line, we will have to continue from the last letter, meaning A, B, C, and then that is going to be point D. A question would be, what is the distance or the length from point C to point D? Remember, guys, this is what I emphasized on yesterday's lesson to say, analytical geometry is a game. What type of a game? A game of two things. Very, very much important, ladies and gentlemen, that at all the times you always remember that. Why am I saying analytical geometry is a game of two things? It's because at all the times, for you to use the distance formula or for you to see yourself using the distance formula, you need how many things? Two things. What are those two things? As part of your notes, just note down to say analytical geometry, it's a game of two things. So that means the moment you see yourself using this formula, you must be having two things. What are those two things? Order, honorable members. Remember to mute your mic, honorable members. Just make sure that your mics remains muted. So let's see. What are the two things that you should be having? It's either you have 2 points. 2 points we are referring to, for example, point A having the coordinates x and y, and also the second point having 2 coordinates x and y. If you don't have 2 points, then you must be having a 1 point and an answer. Remember, guys, I just indicated that in this same lesson, you might be having grade 12s who also attended my yesterday's lesson in grade 12 classroom. So to them, it serves as a revision. I'm telling you, I notice you are there. You might get bored in today's lesson because you fully understood what was explained yesterday, but I would advise you to remain until end of the lesson. That's how you then have a better understanding. Okay, so this is what I was saying. It's either you have a point and an answer. What do I mean by that? For example, examiner might give you point A having the coordinates x and y. And what do I mean by an answer? That means they will give you the distance, which could be maybe 2 square root of, let's say, 14. So can you see? It's a game of two things. when we say a game of two things, we are not saying 2 points or 1 point and answer. We are saying two things. What are those things? It could be 2 points, it could be 1 point and an answer. Very, very much important, ladies and gentlemen, that you remember that at all the time. So that's all that I wanted you guys to be aware of regarding the distance formula. I'm pretty much sure that you do know how to apply that. So very quickly, let's move on to the second part, being the gradient. So when it comes to the gradient, remember, analytical geometry, a game of two things. So we have a small letter m representing the gradient, which is equals to change in y over change in x. What does change mean? This sign, it's actually called delta, which is a Greek word which means change in English. Change means whatever 2 minus whatever 1. What is the whatever in this case? Is y. So that means it's going to be y2 minus y1 over whatever 2 minus whatever 1. In this case, what is the change? Is the change of x. That is why we're saying x2 minus x1. Bantu bakithi, analytical geometry, a game of two things. The same applies when you determine the gradient. Let's maybe try to visualize what is meant by the gradient. I know there's someone in this group who's staying that side of Pretoria North. I'm not sure if Kolahano is there, but his friend has just joined. So these are those mountains, honorable member, that side of Pretoria North. So I want to try and help you to visualize what is meant by the gradient or the slope. So let's say this is a mountain. You want to climb it from either that side or this side. So averagely, let's say from this point up to that point, the gradient between point A and point B, when you compare it with the between, let's say, point C and point D, you can see that this gradient or slope is steeper than this gradient or this slope from point A to point B. So on a Cartesian plane, having the y and the x-axis, that point being the origin. So that means if you are having a line similar to that, you can say, okay, this is a line, and you can see averagely the gradient is as it is. But when you compare the gradient of this line, for example, with the gradient of this line, you can see this one has got a steeper gradient and this one has got a gentle gradient. That is why you will find that the gradient of this line maybe is more when you compare it with the gradient of that line. So that means if you've got two lines and you've just determined the gradient of both lines, you know which one has to give you a bigger value, and the reason to that is because it is steeper. Okay, analytical geometry, a game of two things, meaning the moment you start seeing yourself using the gradient formula, just know that you must be having two things. What are those two things? It's either you've got 2 points. Remember, it doesn't matter whether it's the coordinates of point A and the coordinates of point B. In terms of the letters, they can use any letter. If you remember from the very first lesson that I started with on the 2nd of January, I said mathematics, it is made up of only 3 things. I'm about to reveal some secrets now. Some of you might not have noticed that maths is actually made out of only 3 things. What are those? Number 1, the signs. Number 2, the numbers. Number 3, the letters. I'm telling you, since I started with this lesson, everything that I've been doing, everything that I've been saying, it revolves around these 3 things. What are the signs? We talk about a plus, a minus, a negative. It could be a division, multiplication sign, less than, greater than, less than or is equals to, greater than or is equals to. You can even include it's equals to. It's a sign. There are many more, but these are the main signs that you use in most cases. Voiswa. Someone might learn today that I think ever since you were born, these are the only numbers that you've been using. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'm telling you, you've never ever used any number other than those. Someone is thinking, what about number 10? Bantu bakithi. 10 is the combination of 1 and 0. 902 is the combination of 9, 0, and 2. Hey, what about the letters? We only have from A all the way up to letter Z. Those are the only letters that we use in mathematics. So I'm pretty much sure that some of you guys are able to now realize that mathematics is just these 3 things. They combine them together to form some funny terms and ask you questions based on those funny terms. What's surprising is those terms are funny, but we never laugh. We are always crying and saying, hey, these mathematical terms are difficult. So I had to do that just to remind you that whatever that I'm doing there, Bantu Bagiti, signs, numbers, and letters. I'm pretty much sure that you are able to notice what I'm going to write there. Analytical geometry, a game of 2 things. Meaning you could be given 1 point and also an answer. What do I mean by an answer? If you are using this formula for calculating the gradient, that means you'll be given, let's say, 1 point, and also the second thing that you must be given is the answer being the gradient, which means that's when you'll be looking for another point. Very, very much important, ladies and gentlemen, over there. I'm pretty much sure that all is clear up to this point. Very quickly, let me explain that midpoint, and then from there, we are going deeper. Remember, guys, just in case if I start breaking, just in case if the screen is blurry, let me know immediately, because this lesson is being recorded and sometime in the future you might remember this lesson and want to catch up. So we need to make sure that this recording comes out perfect so that when you catch up at a later stage, you'll be able to watch clearly everything that was explained in this lesson. Okay, midpoint. Bantu bakithi, the word mid coming from middle. Then we can simply say a middle point. Meaning, if you have a straight line having, let's say, A, B, C, D, E, F, and G. So you've got 2 points, F and G. When you calculate the midpoint, being the middle point, that means it's a point between these 2 points, which could be somewhere there. Analytical geometry, a game of 2 things. Because point F, it is made of X and Y. That is why we are going to say, most importantly, when it comes to the midpoint, it's not small letter m, but capital letter M. So remember, we've got x, we've got y, we've got x, we've got y of g, g, and then this is 4f, f. So that means the middle point will also have the x and the y values. That is why you need to then say, to calculate the middle point of the x value, it is going to be equals to, you take this point, you plus it with that one, and then you cut it into half. How do you do that? When you say point of f or point number 1 and you plus it with point number 2 or point of g, the moment you divide it by 2, it means you are cutting it into half. So that means when you say 4, if you see yourself dividing this by 2, it means you are cutting 4 into 2 equal halves. If you have 3, every time when you divide something by 2, just know that you are cutting it into a half. If you have x, the moment you divide it by 2, just know that this thing, you are actually cutting it into half. So that means the power of 2 is that it has the potential to have whatever. That is why here we're going to say that plus that, and then you have it into 2. It is going to give you the x value of that middle point. Similarly, with the y value, you do the same, meaning you're going to have the gradient, the midpoint of y value. It is going to be equals to x of g. You plus it with x of f divided by 2. It doesn't matter whether you say let's see, not x but y. So I just wanted to say, it doesn't matter whether you say let's say in this case x of g plus x of y, x of g and x of f. It also doesn't matter if you do vice versa and say x of f plus x of g. So that is why here I had to do it differently, so that I remember to explain to you that it doesn't really matter that much which one you start with first. That is why, to summarize, at school they are just going to say, to calculate the midpoint, you just say x1 plus x2, then you have it. And then you do the same for y. Y of the first point, you plus it with the y of the second point, and then you have it. It is going to give you the middle point. So that was a quick revision that I had to do regarding the distance, gradient, and midpoint. And most importantly, for these 3 formulas, you always need 2 things, meaning even when it comes to the midpoint, you can be given 2 points or 1 point and an answer being either the x value of the midpoint or the y value of the midpoint. So very, very much important, ladies and gentlemen, that you pay full attention to all the details. You guys are very much lucky because you've attended this lesson where you won't get lost as we go deeper. So now, before I talk much about inclination of a line, is there anyone who's got a question in relation to all that I've explained, of which I assume almost all of you guys are familiar with those 3 things? It was just a matter of revision. Anyone who's got a question, or is all clear from your side? Ayanda the Mayandizi, Mtaka Mkize, are you okay that side, honorable member? Busisi Wengobo, no questions.
No questions, sir. Thank you.
King Mulaudzi, Barimine Pezi Gange, Zotezo Chimbra Zwabudi, Kozianga.
No questions, sir.
Okay, 100%. So I will just make an assumption that no questions from your side at this point. So now I'm about to go deeper. Remember, Kozianga, I'm well aware that you are in grade 12. This same information that I'm providing in this lesson is exactly the same information that I provided yesterday. The only difference is the level of complexity. And I'm telling you now, some of you guys might not have started with this chapter. But most importantly, the moment you do at your school, you will understand it better, and you will understand it better than everyone. And most importantly, not everything might be covered in one lesson, but you will know in which direction you are going. So never, 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 never underestimate the power of your brain. Do not limit yourself to what you are being taught at school. You can go beyond and learn to study ahead. It's going to help you when you get to varsity, where you don't have a program. You just have to know everything that you're being taught. Okay, let me not go deep into politics, but most importantly, let's now start with inclination of a line. This is where I need everyone to listen very carefully. Inclination of a line. Bantu bakithi, I'm about to speak English now. Listen very carefully. Angle formed with the horizontal in an anti-clockwise direction is what we call inclination of a line. Uthini lo muntu lo? Bantu bakithi, ngithi, angle formed with the horizontal in an anti-clockwise direction. This is what we call inclination of a line. Okay, so let's see. This is a Cartesian plane having the y and the x, that point being the origin. You can have a line similar to that. So an angle formed with the horizontal in an anti-clockwise direction. Remember, a clock, what are these things? We used to call them manakan. I'm not sure if you guys are calling those a line with an arrow, but whatever that it is, I'm not sure if it's antenna or, let's say, manakan. I think it's fine, Bantu Bakiti. Let's call this manakana. In which direction are the manakana nakaning? They are nakaning in that direction. What do we call this direction? Remember, this thing is called a clock. So that is why this direction, we call it a clockwise direction. So that means anything in the opposite direction will be called anti-clockwise direction. So just always remember that this direction is clockwise, opposite direction anti-clock. So in this case, we are talking about an angle which is formed with the horizontal. Which horizontal? This line. Can you see? The x-axis is the horizontal line that we are talking about. The angle formed with the horizontal in an anti-clockwise direction. Where is that angle? This is that angle. So now, this line is what we call the line of inclination. And this angle is what we call an angle of inclination. I'm pretty much sure that you guys have been hearing people saying angle of inclination, and it doesn't really make sense in terms of where that comes from. It comes from this horizontal line and the line of inclination. In this anti-clockwise direction, this angle formed is called angle of inclination. That is why in physical sciences you've got a slope there or a surface, and then they give you this angle and they call it an angle of inclination. It is this angle which is formed with the horizontal in an anti-clockwise direction, and you've got a trolley there, either moving in that direction or that direction. So I'm pretty much sure that you guys have got an idea of what is meant by a line of inclination and an angle of inclination. So you have two situations when it comes to an angle of inclination. Let's maybe categorize it into two situations. You've got, let's say, that line on a Cartesian plane again. This angle is what we call an angle of inclination. Remember, guys, I did say on a Cartesian plane at all the times, when you have a straight line ending in the first and third quadrant, it doesn't matter at what slope, but those lines will always have a positive gradient. And straight lines ending in the second and fourth quadrant, they will always have negative gradient, whether you are given a parabola and a straight line, because this straight line ends in the second quadrant and the fourth quadrant, they will always have a negative gradient. For this type of a line will always have a positive gradient. You remember, most we have done an introduction similar to this one, but for functions, and afterwards we have done some exam questions on a function. So just make sure that in case if you missed those lessons, send an inbox to request to be added to our homepage, where you will have access to all the recorded lessons. So remember, guys, it's not at all the times where from the start of this church of ours, I will start preaching the word of God without you guys being given some airtime. You will be given some airtime, you will be asking some questions and whatever, but for now, I just want to make sure that I complete this presentation. If you've got any questions, just make sure to note them down. The reason to that is because I'm well aware that this is actually revision to you. Nothing is new there. So there will be a time where we do some complicated questions where you guys will engage, especially towards the end of this lesson. What I'm actually trying with regards to a line having a positive gradient, so that means for a line having a positive gradient, you will always have a positive angle of inclination. For a line having a positive gradient, you will always have a positive angle of inclination. I just want you guys to remember something. Note it down as part of your notes. Remember, guys, these notes that I'm using to conduct this lesson are posted in our library. So just make sure that you join our online library. In case if you are not in there, also send an inbox and admin will give you a link. So this is what I'm saying. That formula that I spoke about for calculating the gradient, which is equals to change in y over a change in x, it's equals to a y2 minus y1 over x2 minus x1 that we know. This is something I'm not sure if it's new or if it's just a reminder. The whole of that is equals to this trig ratio which says tan theta or tan angle, meaning in conclusion you can say tan angle, it is equals to the gradient. tan angle is equals to the gradient, being that. You will notice how tricky examiner can be in situations where they want you to use this formula. Just always remember that. Tan angle is equals to the gradient. And remember the ratio for a tan. They did not use sine angle, they did not use cos angle. Why? It's because the ratio of tan, it is made of y over x, of which when you look at this formula, you can see that you've got your y as the numerator and you've got your x as the denominator. That is the ratio for what? For tan. That is why gradient is equals to the trig ratio of tan and not that of sine or cos, because this one, the ratio, I think, is y over r, and for this one is x over r. We are still getting to that part of trigonometry. But for those of you guys who are on, let me see, I think I do need to remove all of this. Yes, let me remove. So we do have extra weekend classes where we've started with trigonometry. So just make sure that you are in those classrooms to study ahead. Remember, it's all dependent on the package that you choose. So let's see. I just indicated to you that in this case where you have a line having a positive gradient, you can easily use this formula, tan angle is equals to that positive gradient. So that means you can be given, for example, this gradient and they say it's equals to 2. So that means tan angle is equals to 2. And examiner is going to say, what is the angle of inclination? Then you just do a arctan or second function of tan 2. Then the answer that you get is going to be a positive acute angle. So now let's have a look at situation number 2. So let's say this is a situation number 1. Let's now have a look at situation number 2. So this is where you now have let's say this line with a negative gradient on a Cartesian plane having the x and y coordinates. Remember, angle of inclination is the angle formed with the horizontal in an anti-clockwise direction, meaning this is the angle. But I'm telling you now, because this line, it ends in the second and the fourth quadrant, it is going to have a negative gradient. It is for that reason where we are therefore going to say this formula of tan angle is equals to, because you have a negative gradient, even your angle theta, it is going to be a negative value. Maybe let me do this to say a negative angle. Negative angle, it is not an angle of inclination. But the moment you find a negative angle, it is actually this angle, which is the clockwise angle. Meaning, always, King Molaudzi, when you use this formula and you have a line having a negative gradient, you are going to get a negative angle. Therefore, you need to say 180 degrees minus that angle. You say it is equals to an angle of inclination. Maybe let me do a very quick example, but in your case, write that down. I'll just need to bring this so that I give you guys an example. Let's say on a Cartesian plane, you've got that line, and they say the gradient of this line is equals to, let's say, 3 over 2. And they say calculate an angle of inclination. So I know that tan angle is equals to gradient. What is the gradient? is 3 over 2, which is equals to tan angle. Meaning, angle will be equals to a, what is it? Arc that, or otherwise second function of tan that. What answer are you getting there? Based on my explanation, I'm saying you are going to get a positive angle. Let's see. Shift tan of 3 over 2. Hey, we are getting positive 56. Let me round it to the near. So can you see? That means this is the angle of inclination, which is that. Why was that value positive? It was because I got a positive gradient. That is why I got that angle. And most importantly, your answer has to be less than 90. Because you can see that that line, it is still on this side of 90 degrees. But let's have a look at situation number 2, where you've got that line. Let's say this line, it has got a gradient of, let's say, -3. So that means an angle of inclination, it is actually, let's say, alpha being that one. But remember, because the gradient is negative, we are going to expect a negative angle. Let's maybe do it. Let's say tan of alpha is equals to -3. So that means alpha is equals to that of -3. What are you getting there? I'll just go back and edit that and say -3. Can you guys see? I'm getting a -72 degrees. So what I was saying is that this -72 degrees, it is this angle, which is obviously less than 90 degrees. You can clearly see that our angle of inclination, it went past 90 degrees. So that means already for your angle of inclination, it has to be an angle which is over 0, 1, 2, 3, 89, 90, 91. It has to be whatever number greater than 90. So this value, it's not your angle of inclination because it's negative. It's actually this angle. So that is why I was saying you are therefore going to say 180 degrees minus 72. Whatever answer that you get, it is your angle of inclination. So what is that? So that means that is 108 degrees. So that means this angle, it is the one which is 108 degrees. This is where I'll need you guys to take part and indicate if I'm not confusing you guys with all of that. Guys, am I not losing you with this? Because it's very much important that you understand that. If you don't, I'm going to re-explain based on your question. Does it make sense to everyone? Or is there anyone who's got a question or unsure of something?
We
Smangaliso.
understand.
In case if you want to ask a question, you just click on a button which says unmute. You ask a question and then you quickly mute. Chantal Shabangu. Are you sure, honorable member, you are not lost at that side?
Yes, I'm still fine, thank you.
Hey, Shanti is okay that side. Okay, very quickly, I'll just
Sorry,
take off that. Yes.
so wait, can you please
Honorable
re-explain the
member, on what
example?
point are you rising on?
Could you please re-explain the second example? Tan is equals to negative gradient.
Okay, very quickly, I will just explain that one. To say, unlike that part which is quick, short, and straightforward, always when you have that one having a negative gradient, you are always going to get a negative angle. And then lastly, you're going to say 180 degrees minus whatever angle that you got. It's going to give you your angle of inclination. So let's say, for example, that gradient, let's say it was actually negative 1/3. So that means tan of angle is equals to your negative gradient being that. So now you want to calculate your angle. So let's see what answer are we getting there. Second function of a tan, -1 divided by 3, I'm getting -18. So can you see you are getting -18 degrees. So that angle, it is not an angle of inclination, but it is this angle in that clockwise direction. We know that an angle of inclination is that angle in an anti-clockwise direction. So that means for you to then calculate that angle of inclination, you're going to say 180 degrees minus whatever that you got there, then that will be your that. Let's see, that minus that, it gives you, let's say, 162 degrees. So that means this is your angle of inclination. And you can see your angle of inclination is bigger than 90 because from that point, if you do that vertical line and you use a protractor, you put it there and then you measure the angle formed along that, you will realize that it has actually passed that vertical line being 90 degrees. So you would have been wrong to say your angle of inclination is 18, because the moment you say it's 18, it's more like you're saying it's still on this side. This used to be an angle of 18. So this negative, it reminds you to say it's not an angle of inclination. I'm not sure. Does it make sense, honorable member? Are you happy now?
Get it?
I
Thank
think
you.
honorable member is very much happy. I knew she was going to be very much happy. Okay, so that means I am done with that part. That completed, Hey, now let's quickly move on to equation of a straight line. So I'm going to remove all of this. Guys, analytical geometry is a very simple chapter. You need to score maximum. Remember, guys, at all the times, things are being plotted on a Cartesian plane. So you can have a line similar to that being a straight line. Mzozozo. The question that you need to ask yourself is this line having a positive or a negative gradient? Obviously, it has a positive gradient. Why? Because it ends in that first quadrant and that third quadrant. Most importantly, does it have a positive or a negative C value? You can see that it cuts the y-axis above the origin where y values are positive. If you had a line similar to that, Bantu Bagiti, obviously a positive gradient but a negative C value, because originally all the straight lines were passing through the origin. But because we like to be tricky, we shift that up and down. So that means it was passing there and it shifted by 1, 2, maybe by 2 units upwards. Also here, we can maybe say it was passing through there, it has shifted by 1, 2, 3 units downwards. So that is why for this line, if we know it's 2 there, then it means we already know that for this line, we are expecting y and then plus 2. That's because it is shifted down, which is below the origin. Okay, now let's have a look at that one. Meaning this one, y is equals to already negative gradient. Let's see, c value, okay, it's positive 2 because it is above the origin and shifted by 1, 2 units up. Okay, maybe equals to negative that. Okay, the y value, we see it is you just need to calculate the gradient for those two lines.
Sir, you are cutting.
Denny, am I cutting from your side? Am I still cutting? Moleboge, am I cutting from your side, honorable member?
From my side, you are not cutting.
Last one to confirm. Zozozo, utulile lapho is the kuthe.
You are breaking, sir. Yes, you are cutting.
Konke.
So you're cutting.
Hello, I come back. Is it still breaking?
It's fine now, sir.
Last one to confirm. Okay, I think that was a confirmation to say all is good. Okay, so let's see. This is what I was saying to say for this line, positive gradient, positive C value. Negative gradient, positive C value. Negative gradient, negative C value. Positive gradient, negative C value. So most importantly, you guys need to be aware that we have a general formula for calculating a straight line or determining an equation of a straight line. Analytical geometry is a game of two things, meaning in this case also it's either you are given 2 points or 1 point and the gradient in this case. So every time when examiner says determine an equation of a straight line, just know that they are simply saying find M and find C and rewrite that equation in terms of X and Y. That's what is meant by determining an equation of a straight line. Doesn't matter whether it is that type of a function. When they say determine an equation of a or determine the formula or the equation of that particular graph or function. In other words, they are saying find the A value, B value, and C value and rewrite everything in terms of X and Y. That's what it's meant by determining an equation of a straight line, of which I'm pretty much sure that you guys are not hearing that for the very first time. Okay, so let's quickly see. This is the last point that I want to make, and then from there, we will start looking at the application involving quadrilateral. Okay, this is what you need to remember. For parallel lines, I'm sure you remember this is how we represent parallel lines. For parallel lines, Bantu Bagiti, the gradient of line 1 is equals to the gradient of line 2. So that means on a Cartesian plane, if you have this line and they say is parallel to this line, let's say this is line 1 and this is line 2. If we already know that the gradient of this line, question is it positive or negative? Because it ends in the first and the third, it means it's going to be a positive. Let's assume it to be positive 4. Automatically, it means the gradient of this line also is going to be equals to 4. Why? Because for parallel lines, gradient of line 1 is equals to gradient of line 2. It doesn't matter whether the lines are in that direction. So what matters the most is that you know for this line you are expecting a negative gradient, meaning if the gradient of that line is that, and they say this line is parallel to that line, automatically gradient of this line is equals to that gradient. I'm pretty much sure that everyone understands that part. You will notice how examiner can try to be tricky. So, number 2, for perpendicular lines. In this case, gradient of line 1, when you multiply it with gradient of line 2, I'm telling you, they will always give you -1. So that means if you take gradient of line 1, you multiply it with gradient of line 2, and they don't give you -1, that means those two lines are not perpendicular to each other. But the moment they give you -1, it means they are perpendicular. That is why your teacher is going to say the product of two lines. If they give you -1, that means those two lines are perpendicular to each other. Okay, maybe on a Cartesian plane, having the x and y, that point being the origin. If you have, for example, that line having a positive gradient and you have that line, it could be a line which continues in that direction. Let's say this is the line of F and this is the line of G. And they might say, prove to us that line F and line G are perpendicular to each other. That means already they are, you just need to prove that the gradient of that times the gradient of that, it gives you -1. Or sometimes the examiner might say, is line of F perpendicular to line of G? That means you need to determine the gradient of that. Maybe you might find it to be 2. Obviously, it's going to be a positive gradient, which is going to be +2. For this one, you might find it to be, let's say, a -1/2. So that means for you to prove if this and that are parallel, you will need to say the gradient of line 1 being 2, you multiply it with the gradient of line 2 being -1/2. What will the answer be? You get -1, meaning this line and that line, they are perpendicular to each other, meaning where they meet, they form an angle of 90 degrees. That's what is meant by perpendicular lines. They form an angle of 90 degrees. I have a feeling that this also was straightforward and clear. I'm not sure if there's anyone who's got a question before I move quickly to those questions without having to answer them, but we just discuss how you would work out those questions. So this lesson, it was meant for an hour. As you can see, it took about an hour, but I feel like we can use an extra time to just go through the question paper sent in the group. But very quickly, anyone who's got a question in relation to that, or Smangaliso, are we doing okay that side, honorable member? I see.
Yes, sir. I'm fine.
Tiarao Uyanda. Hey, honorable member, how do I pronounce this? Tiara Lulan. Tiara Luyanda. Are you okay that side, honorable member? Tiara Yolanda. Bosisi Wengobo. Leslie the Leslies. I see Mairu is on the line. Chantal, are we still doing fine that side, honorable member?
Yes, I'm still doing fine.
So,
Thank you.
Umidema Umis, are we okay that side? I know when you're quiet, it means I'm not breaking.
yes, sir, yeah, I'm good.
Mzozozo, uthulile ungathi awufuni ukukhuluma nami namhlanje. Mina ngizokukhulumisa. Ngiphinde ngibhinyelele ngithi kuhamba njani lapho. Mzozozo.
Ngiyakubingelela nami sir. Following.
Ngizokubhinyelela uma ungafuni ukungibhinyelela uzongibhinyelela ngenkani. Wonke umuntu uzongibhinyelela ngenkani, ngiyakutshela. Ngiyakwazi ukuthi umzozozo angeke angikwatele. Ngingalokho angibhinyelelile. Mzozozo, ngiyathemba ukuthi awungihleki that side. Ngiyazama nami. Ngiyazama.
Ngiyakuhleka sir. Hayi awuzama ukwazi.
Bantu bakithi, what Mzozozo said, as I translate, she simply means I'm very, very good with Zulu. So that's what she's saying for those of you guys who do not understand Zulu. Zozozo, ungahleki ntombo, ungahleki lapho, ngiyakuzwa. Noma umutile mic wakho, ngiyakuzwa ukuthi uzaphinda futhi uyangihleka lapho. Let's see. We are having a Cartesian plane, Bantu Bakiti. Very quickly, I'm going to try and draw or redraw what has been drawn. Let's see. This is what I'm trying. Moleboge, can you see that it's more advantageous to see a repeat? I'm not sure if you can feel it, honorable member.
Very true. It's advantageous.
Because you now understand these things better. Muleboge attended a lesson that I did yesterday, exactly the same lesson. And through her questions, she was able to make me explain even better and go deeper. So I'm not sure what she's doing today, but I can suspect she is also enjoying this lesson and she's just here for control. So let's see. This is what you are given, and you're given a statement there. Just in case if you're wondering, where am I looking at this? Is that question that was posted in the group. Question number 3. This is where we are now. Application involving quadrilateral. Quadrilateral, I think it's something that has 4 sides. 1, 2, 3, 4, which could be that being a trapezium, which could be a square, which could be a rectangle. So again, you can have something similar to that. So that means it's in most cases where you might need to expect a type of a shape that has 4 sides. Let me quickly read that statement. So it says, in the diagram, A being a point has the coordinates of 5 and 3. B being that point having 0 and a half. C being that point, and E being that point are the vertices of a trapezium having BA being parallel to CE. The vertices. Bantu bakithi. Vertices means the corners. Vertices means the corners. Hey, talk to me direct. Don't go through the corners. Talk to me direct. Don't go through the corners. Talk to me direct. Don't go through the vertices. Okay, so what vertices are they talking about? This is vertex number 1, vertex number 2, vertex number 3, vertex number 4. So that means under analytical geometry, when you are looking at application involving quadrilaterals, you do know very well that you're looking at a shape having 4 vertices. Let's maybe quickly have a look at the first question. But most importantly, when you look at this diagram, you are able to realize that whatever that you are given on that statement, it is diagrammatically represented on a Cartesian plane, having D being this point, being the y-intercept of that line being CD. Most importantly, because of this and that, it simply means from here to there is equals to from here to there. So that means this is equals to that. Very, very much important, ladies. Okay, so let's see. 3.1, calculate the gradient of AB. And they are going to give you 2 marks. Remember, I said analytical geometry, a game of 2 things. So that means the moment you know, you need to use this formula. It's either you have 2 points or you have a point and a gradient. But in this case, you are given 2 points, meaning you can easily calculate the gradient of that line. And for you to know that is correct, it has to be a positive gradient. Why? Because if you extend this line, you realize it ends in the first quadrant and the third quadrant. Most importantly, before we even go deeper, because they said BA is parallel to that, meaning the gradient of this line also, it has to be a positive gradient, which is the same gradient as that line. So that's how examiner can try to be tricky and try to confuse you. But I'm telling you, because you attend my church, ukhumbule, umbishop wenu ngimi, mzozozo ngimubishop mina, ngoba u-attende esonto lami. You will never get lost in exam. Never. At all the times. Remember what you can remember about my lessons. I'm telling you, you will be laughing in exam and everything. I mean, everyone will be surprised and asking, but hey, I forgot to let you guys know that in mathematics, we do not waste much of our time laughing. Quack, 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 quack. No, 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 no. In mathematics, you just say, okay, you are done. Maybe over the weekend, that's when you can finish off the laughter. But mathematically, you just say, okay, don't waste time in mathematics. Okay, 3.2, determine the equation of CE in the form y is equals to mx plus c. I'm telling you guys, analytical geometry is a game of 2 things. But now, do we have 2 things? Hey, you calculated the gradient of AB, of which it is the same as this one. So can you see what I meant when I said it's either you have 2 points or you have 1 point and an answer. An answer has been indirectly given to you, or you've calculated it. So you just substitute it there, and then you use that point being point E to calculate the C value. Then you give an equation of a straight line. So can you guys see all that I've presented in the beginning of this lesson? It's all that you needed to know it's all that you need to be aware of. I'm telling you guys, when you get to this chapter, it's going to take you some time to complete it, but yourself, you've completed it already. There's nothing else that you need to know other than what I've just explained to you guys. In case if they talk about an area, you know the formula to calculate an area of a triangle. Okay, let's see. Calculate the coordinates of C. Remember, guys, I'm just explaining to you how you would approach this type of questions. Tomorrow, that's when we'll be solving for those questions. Even upcoming lessons will be solving for those questions. But for today, I'm just guiding you in terms of how you approach those. So on your free time, you can try to work it out. And then tomorrow, it's going to be as if you're doing corrections. Calculate the coordinates of C. Sure, examiner is smart. Very, very smart. I'm telling you guys, once you determine an equation of this line, indirectly, that's how you get this y-intercept. Let's say maybe that on your equation you get, let's say a negative, it's going to be a positive. Let's say maybe, for example, the gradient was 2x, and then this one is going to be negative because it has shifted downwards by whatever units, let's say 4. So that means already, if you know that this is negative 4, that means here you actually have 0 and negative 4. And they want you to determine the coordinates of C. And most importantly, they said from here to here, it's equals to there to there, meaning this is a midpoint. So that means you might need to use the midpoint formula. Here comes a question. Analytical geometry, since we know that it's a game of two things, do we have two things? Yebo noma cha? It seems like we do. We've got an answer and a point, meaning you just need to calculate another point. Take wase George Kwak. Hey, mzozozo, iningi i-information into abantwana bazayiniki yona isikhathi kushokuthi inikezeni isikhathi lifunde lezi zinto zilula, and futhi zilula kakhulu kabi, ufuna isikhathi nje. To those of you who do not understand Zulu, this is what I'm going to say. You get it? Someone please fill in the missing word. If you don't get it,
forget about it.
forget about
Forget
it. So
about it.
ladies and gentlemen, 3.3.2 says area of quadrilateral A, B, C, and D. So this is where you need to be dramatic. Hey, but legendary. Hey, a dramatic kakhulu kabi. This is where you need to be dramatic. Let's see. Can you guys see that? If you do that, you've actually made this to be remember, I just redrew that. You've got a rectangle there and a triangle there. So you can just use the area to calculate for this being half length times height or breadth. So the area for this one being length times breadth. Then you can plus the two areas together. That is the area of a trapezium. So that means you will need to use for example, this point and that point to know the length from there to there. You can still use this same point and that one to know the length from there to there. Then that's where you substitute your length and your length. Then, since they said from here to there is equals to there to there, you already know from there to there. Then, since you know the distance from there to there, you can still substitute it there. Then that means it's going to give you that area. And then this one is going to give you that area. And then this area plus that area is the area of a trapezium. Massively important, ladies and gentlemen, that you pay full attention to all the details. I'm pretty much sure that you guys are smiling there and feeling like this is a great 10 question paper. But I'm telling you, you guys are in grade 11, but this is a grade 12 question paper. And you can still be able to understand how to work out some of those problems. That's why I was saying, the information is the same, but the level of difficulty is the one that is different. So if you can already understand this question, that means your questions in grade 11, they should be very, very much easy. So when I choose questions that I know that they are going to make me expand and make sense of what I'll be talking about. I don't just choose any question, and also I don't restrict myself based on the grade. I can still be doing a grade 10 lesson and still use a grade 12 question paper. That is because I know there's a certain agenda that I want to push. And I'm telling you, just like you guys are understanding all that I'm explaining, they will still understand whatever that I'll be explaining. So it's not really about me teaching you guys, but it's about me transferring the knowledge. They will teach you at school. Me, I'm not a teacher. What am I? Guys, my name is Desmond. That's who I am. Let's see. I think those last few questions, we will look at those in tomorrow's lesson. But very quickly, when they say if a point is reflected or is a reflection of E in the y-axis, if you are having a point there and you reflect it about the y-axis, that means this is a point which is there. You just take it from there and you reflect it. Then that point, it is going to be there. So if this point, let's say, is 2 and 4, when it comes to this side, because it reflected about the y-axis, it's only x that changes a sign and it becomes negative. If it was reflected about the x-axis, you take it from there and you plug it this side. So that means if it reflects about the x-axis, it's only y that is going to change, meaning it was going to be a 2 as positive, but having a negative 4. As you can see, it's on this side where the y is negative. You will understand that better tomorrow. Hey, calculate the perimeter of a triangle KEC. If you don't know what a perimeter is, you are in trouble. A perimeter means the length of this side. You plus it with the length of this side, you plus it with the length of that side, you plus it. So that means perimeter is length 1 plus length 2 plus length 3 plus length 4. An answer that you get is the perimeter. If this is 2, this is 1, this is 3, and this is a 2. That means the perimeter is equals to 2 plus 2 plus 1 plus 3, which is what? 4, 5, 6, 7, 8. So that means the perimeter is 8. If these lengths are in meters, it means it's 8 meters. Millimeters, 8 millimeters. Centimeters, centimeters. Kilometers, kilometers. But if you don't have units, you just say 8 units. That's 8. The last one, calculate the size of KC Kepisana E. This thing means in triangle KCE, find angle C. Order order, honorable members? Is there someone who wants to rise on a point of order?
P is equals to 2 plus 4. I mean 2 plus 2 plus. I get to make it 10 or 4.
Did I calculate it incorrectly, honorable member? Let's see. You know, most Matapelo, ngithanda ukusiyenza ingcondo, and these things, they end up hammering me. Let's see. 2 plus 2 plus 1 plus 3. This is 5, 6, 7, 8. Oh, yes, no, it's 8. Matapelo, on what point are you rising on, honorable member?
P more is equals to P is equals to 2 plus 1 plus 4 plus 2. P is equals to 2 plus 2. Next at 1 plus 3.
Oh, no. Ki 1. So, ki 2 plus 2 plus 1 plus 3. I was just giving an example, but you just need to remember that a perimeter, you just add the sides. Why one?
There.
Okay, so the last one, very quickly, size of that. So you will need to refer back to that and look for triangle K. Hey, can you see K is not there, but K is that reflection. So that means you had this point which has reflected to this side, and you know when it reflects about that, X is the one that changes, meaning you are having a negative 6. It's no longer positive 6, but it's negative. So that means the triangle that they are talking about, you might find that it is actually that new triangle. And then you will need to know the angle that they are talking about. Let's see, where are those points? C, they're saying C, K, and E, and they want angle C. Okay, so that means this is what you are having. This is that point C. This is that point E, and this is that new point K. And you know this is 90 degrees there. Why? Because this thing, it just reflected about that. So that means it just forms that straight line. And also here, when you calculated the coordinates of C, you might realize that also your X value is -6 because I've worked it out, but we'll see tomorrow. And then lastly, that's what makes it to be 90 degrees there, because it is along the same X value and it is along that same line. It makes it 90 degrees there. So this is the angle that they are looking for. The question is, did you not calculate this length, Bantu Bakiti? Maybe you have calculated that. If you found that to be 4, that means from here to there, because they said this and this are equal, that means also this is 4. So that means from there to there, it's actually 8 units. So you might need to then calculate that length from there to there, and then you know whatever that it is. Let's say maybe, for example, it is 7. So can you see, you can use the trigonometric ratios, either tan, either cos, or sine, in order to calculate that angle. Obviously, you can't use that because you don't have an adjacent. Since you don't have an adjacent, it means you can't use cos. But sine, being opposite over hypotenuse, it could be the suitable ratio to use in order to calculate that angle C. I'm sure you guys have learned something out of today's lesson, but most importantly, tomorrow we are going to then work on this question from the start till the end. Yes, honorable member, you are recognized. What's your point of order? Voiswa, what's your point of order, honorable member? On what point are you rising on? I can't hear Vuide Mavuiswas. I'm not sure if you guys can hear Vuiswa. Guys, anyone who's got a question before I sign out? Any question before I sign out? Bosisiwe, have you got a question, honorable member? I'm about to sign out. But I think I will have to sign out because tomorrow it is still grade 11 mathematics. So we will still be discussing all of this. So just in case, if you've got a question, you can still raise that tomorrow. So let's say the code for today, to show that you've attended today's lesson, comment with your initials. So if you are Desmond Seko, then just comment DS. I'm sure those who did not attend, they will not just comment. They won't be able to crack that code. So the code, we use it to know who has attended, so that when your parents ask, how is our honorable member doing, then we're able to scroll up and check if they have been attending. If you do not comment, it's more like you haven't attended. 3 months later, when we try to check who has been taking their lessons seriously and we don't see your comment there, it's going to be difficult to help you, even if you say, I was practicing this and I'm getting confused. I'm just going to try and scroll. If I don't find your comment, then it's an indication that you should be surprised. No, you should be confused because you were not attending. So guys, this is your code for today. My name is Desmond. You guys have a very good night, and I'm out.